Okay, can somebody confirm that you can hear me?
I can hear you.
Thank you. So today is July 18th, and we will be discussing Lab 3 today. Let me share my screen. My computer is a little slow because it's still converting the lecture. Yep, it might have just finished. Let me take a look at that. Yep, it did finish. All right. So my computer will start working better now. Before we begin, are there any questions? Let me inform you that you need to pick a infectious disease project and get it cleared with me. You cannot choose a project with getting it cleared with me. I want to make sure everybody has a separate project and meaning a different disease with some exceptions, like I can split influenza A and from influenza B, things like that. But it is a separate disease, no sense. And I also want to make sure that it is an infectious disease and narrow it down if it needs to be narrowed. All right, so today we're covering Lab 3, Microscope Basics. Any question about anything? Lab Module 3, Microscope Basics. You're not going to be working with a microscope, but you do need to understand how to use a microscope. So read the lab module and the class textbook through chapter 3 through the end of the section on compound light microscopy. We do have some video clips for you to watch and an online exercise where you'll be using a microscope online. The learning objectives, you're not physically going to be using a microscope. However, upon completion of this lab module, students should be able to locate and name the parts of a compound microscope and be able to describe their functions, be able to calculate the total magnification for each objective lens used, know the guidelines for focusing specimens with different objectives, meaning we have different objective lens, a scanning lens, a scanning objective lens, a low objective lens, a high objective lens, and an oil immersion lens. And I do not typically use these names. I call the scanning objective lens the 4x objective lens, the low objective lens, the 10x objective lens, the high objective lens, the 40x objective lens, and the oil immersion lens, 100x objective lens. I particularly do not like using low and high because the low objective lens is not the lowest, the scanning is, and the high is not the highest, the oil immersion is. Is that clear to everyone? All right. Then next, be able to estimate the size of a specimen when seen at the different magnification powers. Meaning, if I tell you what objective lens has been used in a photograph, and you see the size of an object, you can tell me the exact size of an object knowing the objective lens and the power of the objective lens. And then be able to understand the rules for proper microscope care. You're not going to be using a microscope in this lab other than an online microscope, but you must know the correct way to use a light microscope from this lab. And then lastly, be able to define the terms associated with microscopy. All right, any question about the objectives? So the first thing you need to do is memorize the names and the function of these parts of the microscope, shown here. One is the ocular eyepiece, also called the eyepiece or just the ocular lens, and it will magnify the specimen that you're viewing. Two is the objective lens, and on our microscopes you have four. I can only see three there. I only see three there, but there's one being hid there. Actually, there's a fourth one right there. One, which is largely hid. One, two, three, and then the fourth one there. In our microscopes, and then this is true for the microscopes in the microbiology lab at Clark College, our objective lenses have four lenses on a rotating nose piece, and you can rotate this around. That would be the 4x lens there. That's the 100x lens there. Next to the 4x lens over here, which you can barely see, is the 10x lens. And then the 40x lens is that one which you can barely see there. And actually here you can see the 4x lens there, the bottom of it, that's seeing the 10x lens. And there's the 100x lens. And you can't see the 40x lens, or at least I'm not seeing it here. The objective lens will magnify the specimen that you're viewing. So both the ocular lens and the objective lens will magnify your specimen that you're viewing. You should know the stage. That's where you put the slide down on, and then the stage clip will hold the slide and then will allow it to be moved, meaning this is a clip and it will actually close in on the slide to hold it in place. And then you use the stage controls here to move the specimen this way and that way under the light source. So the stage controls. 5, 6, that's the iris diaphragm, which can open and close to allow in more light or less light. And you can get better, cooler illumination from that, as well as see your specimen better. 7 is the what the heck is that called? Just a minute, I'm drawing a blank here. The condenser, no, that's the yeah, it's the condenser, which is a lens, but it doesn't magnify the specimen. It simply focuses the beam of light coming from the lamp into a cone to come to where you're viewing. And you want to adjust the iris diaphragm to change the size of that cone of light coming up to your specimen. So for best illumination, meaning using Kohler illumination, you want the size of the beam of light coming up through where your slide is to be equal to the size of your field of view under the objective lens. So in short, when you're at the starting with the 4x lens, you should have the cone of light open, or the iris diaphragm open, so the cone of light is large, so that the entire field of view that you can see with the 4x lens has a cone of light coming up. And then as you go up in power, you should start closing down the iris diaphragm to adjust the cone of light. So once again, it's to the size of your field of view. And the 10x lens has a smaller field of view than the 4x. And the 40x lens right there has a smaller field of view than the 10x. And then the 100x lens has a smaller field of view than the 40x. So as you go up in power of the objective lens, you should be shutting down your iris diaphragm. And when you get to the 100x objective lens, you should shut down the cone of light essentially to a pinprick, because, well, a little larger than a pinprick, but something like that. Because that's all the field of view that you can see with the 100x objective lens. And that we'll talk a little bit about this later, but that will improve your resolution by increasing the contrast and then giving you enough light to see the specimen. Any question about that? 8 is the coarse focus knob. That's the large one that will move the stage up and down fairly rapidly. 9 is the fine focus knob, and it will move the stage up and down minutely. 10 is the light switch. You turn that on to turn the lamp on. 12 is the lamp, by the way. 11 is what we call in America the rheostat, and you can turn this on to increase the intensity of the lamp or decrease it to decrease the intensity of the lamp. And apparently in Australia, they don't use that word, rheostat. And so the lab module has calls it the light intensity dial. Any question about any of those? Of course, the lamp is the light source. So those are the different keys for the different parts of the microscope you need to know. This table you should also know, and that is it gives the name of the objective lens, and then the power of the objective lens, which I use it for its name, and then the total magnification of the objective lens. So the objective lens 4x magnifies the specimen 4 times, but the total magnification is the power of the objective lens times the power of the ocular lens. All of our microscopes in microbiology lab at Clark have a 10x magnification in the ocular lens. Now, not all microscopes are that way. Like a child's microscope can be less than 10x, and I've never seen anything about a child's microscope be less than 10x, but I suppose it's possible. And then the very best and most expensive microscopes have an ocular lens of 20x. And obviously we at Clark do not have the best and most expensive light microscopes. Okay, so the total magnification for our microscopes would be 40x for the 4x lens or the scanning lens, 100x for the 10x lens or the low power lens, etc. So you should know the total magnification. You should also know the depth of field. When you have a slide underneath the microscope, you generally cannot see all of the slide. You can only see sorry, that's the field of view. Let's go with this one. When you're looking at an object under a microscope, you will have an object which will have some depth to it. So this box here has some depth to it. With the 4x lens, objective lens, it has the deepest depth of field. So you might be able to see both the top and the bottom of an object when using the 4x lens. With the 10x lens, it will not have as much depth of field. And basically, it'll be about half the depth of the 4x lens. So instead of seeing both the top and the bottom, you would only see the top down to about halfway. Now for the 40x lens, it would be even smaller, and you'd only see the top down to, I don't know, maybe 10% of the box. And for the oil immersion lens, it has a very narrow depth of field. Essentially, all you're seeing is one plane through the object. And you can focus in on the top of the object or the bottom of the object, but that's all you will be able to see, at least in focus. You would not be able to see the middle of the object, regardless if you're focusing on the top or the bottom. All you'd be able to see would be the top of the object. Any question about that? Now, the field of view is the amount of the slide that you're seeing. With the 4x lens, you have the largest field of view. So I guess we'd go something, well, let's go something bigger than that. So this is your slide, and the field of view will be a fair amount of the slide. Not all the slide, but a fair amount. And then when you go to the 10x lens, you'll have a smaller field of view. And you move up to the 40x lens, you have a smaller field of view. And then when you go up to the 100x lens, you'd have a very small field of view. Any question about that? So comments, the 4x lens is the easiest to use because it has the greatest depth of field and the largest field of view. You'd be able to see the object on most parts of the slide, not all parts of the slide, but a large part of the slide. And then regardless of where you're focusing, you should be able to see the object, and it'd be the easiest to see the object because it has the largest depth of field. And then the 100x lens is the hardest to use because you're seeing the very least amount of the slide possible. And then you have to be focused directly on the object in order to see it because you have the smallest depth of field. In fact, you really only have a depth of field of about one plane. Any question about any of that? All right, you should know that when you see an object under a light microscope, the image will be more than just magnified. It will be magnified, but it'll also be inverted and reversed. So the letter E under the light microscope will look like this. Any question about that? All right. The iris diaphragm has a diameter which can be opened or closed to allow either more or less light through up to the specimen. More importantly, though, the iris diaphragm affects the contrast of the specimen against its background, meaning if you want to see the specimen, you have to have the iris diaphragm at the correct opening in order to have good contrast between the specimen and the background of the slide, which is just glass. So when you're first beginning with the 4x lens, you should have the iris diaphragm fairly open. And then when you go up in power, you start closing down the iris diaphragm. And then this lab tells you the iris diaphragm is the most important tool in light adjustment. And there's actually a question of that in the lab, but I never mark people wrong if they say the rheostat or the light intensity knob is the most important tool because both the rheostat and the iris diaphragm control the amount of light that you're getting on the specimen. Tips for focusing. When you first use the microscope, you should unwind the cord, turn on the microscope. Obviously, I have the microscope plugged in, and use the 4x lens in place. Then you use the coarse adjustment knob to slowly adjust your focus, to slowly raise the stage to being the object into focus, coarse focus. Once you have it in coarse focus, you then use fine focus to get the focus just perfect, or as good as you can get it. From now on, you do not use coarse focus knob any other time unless you're working with the 4X objective in place. Whenever you go and use a higher objective, you should never use the coarse focus knob. You should only use the fine focus knob. The reason for this is because our microscopes have the objective lenses in parafocal vision, meaning that when you have one objective lens focused, all other objective lenses should be either focused or very close to being focused. And all you should need to do is adjust the fine focusing knob to get the focus finely focused. So when you first use the 4X lens, you use the coarse focusing knob and then switch to the fine focusing knob. Move the center of your specimen into the center of the field of view of your specimen. Let me use something a little bigger again. The reason being is if you're viewing something over here in the field of view, and then you go up in power, that object will be outside your field of view because the next power will have a less field of view. So always before you move up to the next higher objective lens, move what you're looking at, the object, into the center of your field of view. And then switch the objective to the higher objective lens, the next one, and only use the fine focus knob because both objective lens should be focused on the specimen or very close to it because they're parafocal. And then repeat that step whenever you change your objective lens going up, meaning move the specimen to the center of your field of view, change the objective lens to the next higher one, and then only use the fine focus. If you make a mistake and use the coarse focusing knob, you may as well start all over again and go back to the 4X lens and then focus again on the specimen. Because if you use the coarse focusing knob, the specimen will not be in fine focus. Any question about that? All right, for using the 100X oil immersion lens, it's a little more complicated, and that's because oil has to be added to the oil immersion lens to get the resolution to be better than the 40X lens. So if you don't use the oil on the 100X lens, you may as well only use the 40X lens because the 100X lens won't be any better than the 40X lens, and the resolution won't be better, and the 40X lens will be easier to use than the 100X lens because it has a larger field of view and a greater depth of field than the 100X lens. But what you do for using the 100X lens is you take the 40X lens and you do not totally move it out. You move it halfway out of focus, and you do not move the 100X lens into place. You only move it halfway into place so that over the specimen, I don't know if you guys can see this, I'm trying to show it. The specimen will be right here, and you don't have any of the objective lens directly over it. That should allow you to come in with a drop of oil and see if I got something similar to a drop of oil. Obviously, I don't have oil with me. And bring in the drop of oil and put it on where the specimen is. Just one small drop of oil right there. And then you move the 100x lens into the oil. The oil will, meaning the 100x lens will be close enough to the slide that the drop of oil will be something like that on the slide. And when you move the 100x lens, you will actually put the 100x lens into the drop of oil. That will cause oil to be between the glass slide and the glass of the objective lens, which will improve resolution. And we'll talk, excuse me, we'll talk more about that in the lecture, but for here, we're just going to say it's improving the resolution. And the reason is because oil has the same refractive index as the glass of the slide and the glass of the objective lens. And that will reduce the refraction of light, and that will increase the amount of light getting into the objective lens. And we'll talk more about that later, but for now, I'm just going to leave it at that. Any question about that? All right. So once you've used oil with your 100x lens, now when you're all done with the microscope, you need to clean the oil from the 100x lens with lens paper. And you guys will only be using lens paper with the microscope to clean it, meaning you could use Q-tips, cotton Q-tips, but most students don't. And you could use a lens cleaner, but usually if the student had a problem in the lab and they would say, my microscope isn't clean and I've cleaned it with lens paper, and could you clean it? And I'll get the lens cleaner, put it on the lens paper, and then clean the lens and then dry it with the lens paper. So most of the time it's the professor who cleans it with the lens cleaner. Students don't. And very rarely would you use the Q-tip, because mostly it cleans the ocular lens and you don't put oil on the ocular lens. So you will only be cleaning it with lens paper. All right. So the activities for this lab, activity 1 is going to ask you what's the size of the field of view. Online students will not perform this activity with a real microscope. Therefore, the table has already been filled in for you. However, you will be expected to know the information contained in the table or how to use the formula in point 5 below. You can either memorize the information in the table or learn the equation or the formula in point 5 below. And that will give you the size of the field of view under the objective lens that you're using. So you could calculate it with this formula here, meaning the diameter of the field of view in millimeters of whatever objective lens you're using times the diameter of the 4x objective lens times the magnification scanning of the scanning objective lens, that's the 4x lens, times the magnification of the objective lens you're using. For the 4x lens, the diameter of the field of view is 4.5 millimeters or 4,500 micrometers. For the 10x lens, it's 1.8 millimeters. For the 40x lens, the diameter of the field of view is 0.45 millimeters. And for the 100x lens, the diameter is 0.18 millimeters. Now remember that 1 millimeter is the smallest unit of measure with the ruler. And we would give our students in the real in-class lab, microbiology lab, a ruler, and then ask them to measure the diameter, and then they write it up on the board, and then we get it. And generally, the average is usually 4.5, 1.8, 0.45, and 0.18. But the point is, these two, the students often get wrong because the smallest unit they have on the ruler is 1 millimeter. And so they have to estimate this size, and especially estimate this size. Any question about that? And for the online class, we just fill it in for you. And you do need to know these questions for answering some of the questions, meaning you do need to know this table for answering some of the questions in today's lab. And then why is it important to know the diameter of the field of view for the different objective lens? It allows you to estimate the size of the specimen that you are observing. For example, if you are using, we used to use the 10x objective lens, and you have a specimen that takes up half of your field of view of the 10x lens, you can then give me the size of the specimen, which is half of the field of view, and the field of view is 1.8 millimeters. So the specimen would then be 0.9 millimeters, or half of the field of view. Any questions about that? So you do need to know the diameter of the field of view with each objective lens so that you can tell me the size or estimate the size of the specimen that you are viewing. Activity 2, you're going to be observing prepared slides. This will be an online activity. You're going to be using a virtual online microscope for this activity. And you can find this at the end of the document. We expect you to know and understand the material in this exercise. So read through the activity. Oh, I haven't talked about why we clean the lens only with lens paper. Paper, regular paper like this, whatever you call that, paper towel, chem wipes, regular paper, has wood fibers in it. And wood fibers would be able to scratch the lens. Since the magnification lenses, both the objective lens and the ocular lenses, are the most important part of the microscope and the most expensive, we do not want these lenses damaged. And if they get damaged, the student would have to use that damaged lens for the rest of the term. And if it's damaged, it'll be harder to view. You won't see things as clearly. And so we use only lens paper to clean the microscope. And lens paper is paper that the wood fibers have been removed from it. Any question about any of that? So lens paper does not damage the lenses. All right. Activity 3, you should read about if you do not know how to make a wet mount, but we are not going to perform this activity and you're not going to be tested on that procedure. But if you don't know how to make a wet mount, you should read activity 3 because it's a very useful procedure to use in microbiology, how to make a wet mount. And we will talk about wet mounts in this class. So you should know how to make a wet mount. All right, you're not going to be handling a real microscope, but you are expected to know how to correctly store and handle a microscope. So after you're done using a microscope, you should lower the stage all the way down, remove the slide. If you used oil on the oil immersion lens, you should remove oil from the 100x objective, as well as remove any oil from the 40x objective lens, meaning that the 100x lens will get in that drop of oil because it's going to be so close to the slide. But if you happen to rotate the objective lenses around, and you happen to rotate the 40x objective lens through that drop of oil, it is close enough to the slide that it too will pick up oil. And if it picks up oil, you should remove the oil from the lens, because oil, if it dries on the lens, will be very difficult to remove, and you will not be able to see through it, or at least see through it clearly. Then change the objective so the 4x lens is directly over the light source. Lower the light intensity to minimum, meaning change the rheostat to minimum. Switch off the light, unplug the microscope, and wrap the cord neatly around the microscope. You can either wrap it directly around the microscope, or most of the microscopes have two knobs for wrapping the cord at the back of the microscope. You don't need to know that, but I'm just telling you, wrap it around the microscope. And I don't have my students move the turret, so you don't need to do that. Number 7. And then always carry the microscope with both hands. Our microscopes are pretty heavy, so most students do carry it with both hands, but you should carry it with both hands, one on the arm of the microscope or on the handle to carry the microscope, and then one arm underneath the base of the microscope to support it. And then with two hands on the microscope, you're much less likely to drop the microscope. And we don't obviously want you to drop the microscope. And then place the microscope back in the cupboard where you got it from, meaning in the same number as you got it from, and in the same position. Our microscopes will have the front of the microscope there, and then the eyepiece is coming back this way. We put the back of the microscope, meaning the eyepieces, towards the back of the cupboard. Know the terms of the microscope lab. And then we have a video for you to watch on how to focus a microscope, and then another video on how to use oil and cleaning oil, but mainly putting on oil. And then for 2, we've got a link for practice your microscope, working on your microscope, naming your microscope. Let me open that. This will take a little time to download, like it's still downloading. And I have a fairly fast network. This is a little slow. There you go. And you can click on the guide to read about the guide, learn and explore. I'm going to just move directly on explore. You must click on explore. And here let me get that out of the way. Explore a variety of slides and magnification in this completely open microscope environment. So you click generally on where the question mark is. And I'm going to have you guys look at the plant slides, look at the onion root tip slide. I'm not sure I got an onion root tip, but I got a slide here. And you need to coarse focus on it. Someplace around here. It's hard to do initially. And then move it to your center of your field of view. It's pretty much in the center of field of view here. then go up in power, and it should be close to focusing if we had it good. Now let's find focus. Something around there. Now let's go up to power. Let me see if I can find. I'm not seeing it yet, but let's try it around here. I want to look in a chromosome, a slide with chromosomes. I'm not finding one yet. Let's go up to the 40X lens and now find focus. And it's a little hard to see the specimen, so I'm going to increase the light a little bit, just a little. And see if I can find focus. There's a cell with chromosomes. There we go. So I'm going to ask you a question about chromosomes. I should make sure that question is in the lab, but hopefully it is. And if not, I'll add it to the lab. But and then let's see if we can go up to 100X lens. And you'll note we don't see anything here, and it's telling you add oil, immersion oil, and there it is there with the question mark. So you put in a drop of oil, and now we need to find focus. Increase the light a little. See if I can get on the chromosomes. I can't get on the chromosome with this one. Well, there it is there. All right. Any questions about that? Then remove the slide because we're done for the moment. And it says lens paper. Whenever you have finished using a 100X lens with immersion oil, it is very important to thoroughly clean the lens and slide with the correct lens paper. Find the lens paper in the scene to clean the lens, and the question mark tells you where it is. Click on that, and that's cleaning the lens, and then put away the slide. And you note it also rotated the lens with the 4X lens in place, because when you put away the microscope, the 4X lens should be put in place, and the stage should be lowered. And then the guide tells you how to do different things here. So the question mark here would be looking at different things. Oh, I did select onion root. Okay, good. I didn't remember. Did I select onion root? But I will ask you a question about the onion root. So you should probably look at that one. And I did show it to you. All right, that's how you use the online microscope. Oops. And then fill in the blanks with the correct answers. Don't do it here because these may not have been changed. And you don't turn in, oops, that's the wrong one. Let me check and see which one I've got here. Nope, this is the lab module. Do not post the lab module. For one thing, the questions will not be updated. And second, I do not want all the students to upload the lab module because it's many times larger than the lab exercises. Only post the lab exercises in the lab, because if everyone posted the lab modules, my web page will become full, and then no one will be able to submit an assignment. Let me make sure I've got the question here. I need to add that question. So I'll do that, after I talk about this. So remember, I'm going to be updating the lab exercises. All right, so answer the question. When focusing a specimen, you should always start with which objective lens? When using low power, high power, and oil objectives, only what focus adjustment knob should be used? And that's either the coarse focus or the fine focus knob. The type of microscope used in the lab is what? And you can't say the light microscope because it's a two-word answer. And don't tell me something like Nikon light microscope, because not all of our labs are made by, not all of our microscopes are made by Nikon. So you need to find a two-word answer there. And it's in the lab module. You should carry the microscope by holding on to what part with one hand and supporting it with the other hand. Supporting what with the other hand? 4E, the objectives are attached to this part of the microscope, which can be rotated to click different objective lens into place. So name the part. If a microscope had an ocular lens of 10x and a high power objective lens of 40x, what would be the microscope's total magnification? 4G, when the stage is moved left, the image viewed through the ocular moves which way? When the stage is moved forward, the image moved through the oculars moves which way? And 4H, which objective lens provides the largest field of view? 4I, which objective lens has the smallest field of view? 4J, of the methods for light adjustment, what is the most important on the microscope? And then 4K, how large is the field of view when using the high power objective lens? Answer in millimeters or micrometers. And I'm going to have a 4, let's see, what's the letter after K? 4L. And then 2, suppose a typical bacteria cell is 2 micrometers in diameter. In the circle below, which represents the field of view, when viewed with the oil immersion objective, state how many cells can fit across the circle under the oil immersion lens. Show your calculations in your answer for full credit. Okay? All right. Any questions about that? I don't have that here. I'll have to add that.
I have a
All right.
question. You said not to send in the actual lab module, but on the laboratory exercises, the questions are different. So you're going to update those?
The lab exercises are different than your lab exercises?
Well, I'm just saying that I printed this out, lab module 3, microscope basics. Okay, never mind. So basically at the end of what I printed off for the lab module 3 microscope basics, page 8 has different questions than the other. There's 2 of them. They look almost identical, but then the bottom K is different and 2 is different on the last page.
Yeah, I want you to have the questions that I've got here, and I'm just adding on here. Question K or question L.
Okay.
Okay. So I'll update that and put it on your worksheet.
Okay, I'll print it out again then.
Well, the worksheet was different?
Yeah, so it's confused because I print the whole thing out. I do better with paper in my hand for reading. So I printed out the lab module 3 and I'm following along.
Yeah, the lab module I know is not updated.
Yeah, so
lab worksheet should have been.
Yeah, one of these
I'm going to update it again, so.
Okay.
All right. All right, let me stop sharing here. You guys work on the lab. I'll be here. I'm going to update the lab worksheet, and I will be here to answer questions until about 9 o'clock or the last student logs out. All right, where is that? Let's close that down. And I thought I had updated that lab worksheet, but obviously I did not.
So I just went back into Canvas and looked. So the worksheet itself, that's just by itself, is updated except for L you're adding.
Yeah.
So it was the actual lab module that wasn't up.
Yeah, the lab module don't use those questions.
Yep.
Make sure I save that. All right, I just updated the lab worksheet to lab module 3. So you should be good to go.
It updated on my end. Thank you.
All right. All right, I'm going to walk away for a minute, but I'll be back in a minute or two. Oop, I'm still recording.